So here is another question on converting 1's complement signed binary numbers to decimal form. So the first one is given 00010100, and the second one is 11011011. So as you can see, the second one is the 1's complement of the first one. So both are the 1's complement of each other. So the first step, which is the assignment of weights, so it's an 8-bit number, both are. So 2 to the power 7, power 6, power 5, 4, 3, 2, 1, 0. So it is 0, 0, 0, 1, 0, 1, 0, 0. So examination of the sign bit, it's 0, so it is a positive number. Okay. Now to convert it into decimal, the 1 bits we have to multiply with their respective weights, power of 2, and add them. So it is equal to, very simple, 1 into 2 to the power 4 plus 1 into 2 to the power 2. So 16 plus 4, that is equal to 20, plus 20, because it's a positive number. Now here, as this is the 1's complement of this, we can write it directly minus 20, because it is the 1's complement of this. As you can see, in place of zeros we have ones, in place of ones we have zeros, the second one. But if you have to show it, then we have to go with the usual approach, that is, again we have to write down the weights: 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, power 3, power 2, power 1, power 0. So it is 1, 1, 1, 0, 1, 0, 1, 1. So here, examination of the sign bit, it is 1, so it is a negative number. Okay, so here what we have to do to convert it into decimal value, we have to put a minus sign to this MSB bit, the sign bit, and to the weight associated with it. So it is minus 1 into 2 to the power 7 plus 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 3 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. And then we have to add a plus 1 to the result. So it is coming minus 128 plus 64 plus 32 plus 8 plus 2 plus 1 plus 1. So it is minus 128 plus 64 plus 32, 96 plus 804 plus 26 plus 107 plus 1. So 107 to 108, so it is minus 20. Okay, it is coming minus 20. So here we have shown it, we have proved it, it is minus 20. So if it is a subjective question, then you have to write all the steps, convert it into decimal, add +1 and get the result. But if it is a multiple choice question, where there are options, so directly just by looking at the question you can see that the first one is +20, as the second one is the 1's complement of the first one, so obviously it will be -20. Just by looking at the bit pattern you can get the result, especially for the positive numbers. Okay, for the negative numbers it can be a bit difficult to identify the pattern, but for positive numbers, here just by looking at the question, see this is 2 to the power 0, 1, this is 2 to the power 2. See, when you look at the bit pattern in the question itself, you can directly attach the weights here. Say this will be 2 to the power 2 and this will be 2 to the power 4. So directly by adding both you can say, okay, 16 plus 4, this is equal to plus 20. Okay, this is the 1's complement of this 1 1 1 0 1 0 1 1, so obviously it will be -20. You get the result. But if it is a subjective question, then you have to write all these steps, okay, to get the result. You have to show it. Okay, so this is it. So here is another question on finding out the decimal values of signed binary numbers expressed in 1's complement form. So the first binary number is given 0110010, and the second one is 1001101. So if you will see, the second one is the 1's complement of the others. Both are 1's complement of each other. So first what we'll do, assign the weights. They are 8-bit numbers, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so the number is 0 1 0 1 1 0 0 0 1 0. So here first we have to see the sign bit. It is 0, so it is a positive number. Then the respective 1 bits will multiply with their weights and add them together. So here it is, the decimal value is equal to 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 1. So it is 64 plus 32 plus 2. So 98 plus 98. Now, as the second one is the 1's complement of the first one, so it is -98. It will come -98. But we have to show it. If it's a subjective question, we have to show it. If it's an objective question, directly you can say it is -98. So again, first we have to assign the weights. 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, power 3, power 2, power 1, power 0. So the binary signed binary number is 1001101. So here first examination of the sign bit. it is 1, so it is a negative number. Obviously it will be a negative number because it is the 1's complement of the previous one. Now we have to assign a negative value to the sign bit, so minus 1 into 2 to the power 7 plus the remaining one bit, it will be plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 0, and then finally we will add 1 to the value. This is the decimal value, so it is equal to minus 128 plus 16 plus 8 plus 4 plus 1 plus 1. So it is minus 128, 16 plus 8, 24 plus 4, 8 plus 29 plus 1. So minus 128 plus 29 plus 1, that is 30. So it will be equal to minus 98. So we have shown it also through addition of weights. So it is minus 98. So the previous binary number, which was the 1's complement of this one, it was plus 98, and here it is minus 98. Okay, so again this is the procedure to find the decimal value of signed binary numbers which are expressed in 1's complement form. So you have to practice more and more questions, get yourselves acquainted with more and more bit patterns so that you can recognize the bit patterns, and directly without any calculation you can figure out, okay, from this bit pattern this is this number, so it is the 1's complement of this, so it will be negative. So it will be helpful for you in multiple choice type questions, which is mostly found in competitive exams where there is a time crunch. If you get yourselves acquainted with more and more bit patterns, you can just by looking at the question you can figure out what the decimal value is, and it will save you a lot of time. But if you are a beginner, I suggest that you proceed in this way to avoid mistakes. It will take a bit longer, but you will arrive at the correct result.